Hey guys, welcome to J.T. Engineering. In this episode, we're going to be building this 1.6-inch GP40 that I designed. I spent about 8 months designing this locomotive and then another 2 months designing the 3D printed detail parts that you'll see later in this video series. The good news is if you want to build this locomotive in your garage as well, all of my files are now for sale at jtengineeringmodels.com. So after this video is done, why don't you head over to that website and check those out. In this video, we're really going to be focusing on one thing, and that's taking the big pile of metal that I had in the back of my truck and turning it into this GP40. It's a little bit overwhelming, so this is going to be a very detailed series about how to build this locomotive. You might have found this video from the other video that I have published that's really an overview of how I built this thing, but this is the nitty-gritty of how to take a big pile of sheet metal and turn it into this. So why don't we go ahead and get started. All right, so to get started on this thing, the first part we're going to need is the floor sheet. We're going to build everything up off of this floor sheet. So make sure you spray down some simple green, get it clean, get it ready to be welded. There is a top and a bottom, and there is a front to back. So it's important to get that right when you're doing this. Otherwise, you're going to weld it upside down. So just really quick, you can see here on the bottom sheet, this is the back portion. This is the rear. You can identify the rear of the locomotive based on these 1, 2, 3 screws. Similarly, the front does not have those. You can see there's no screws in the front. The slots look a little bit different. If you're using the AccuCraft trucks, the top of the sheet, you're going to want to make sure that your truck holes here are oriented correctly. So if this is the front, you want your truck hole to be offset to the right. So this is the top of the locomotive. So I'm going to go ahead and take a marker, and I'm going to write top because I'm stupid as and then I'm also going to write front and rear so I get to hold my hand along the way so I don't mess this up. And then we're going to flip it over and start welding on the back. All right, I know it seems like there is a lot of slots on this floor sheet because there is. So we're going to go ahead and start on the bottom of the locomotive. We're going to start with the frame. So for this, you're going to need your center frame sections, all of your bolster ends as well as your bolster sides, your coupler pocket 1 and 2, and your pilots. So we'll go ahead and get all this mocked up. The first thing we're going to do is we're going to work from the center out. So you can see that I'm dead in the center of the part, and I've got my center frames right here. And if you just line up your tabs here, then this should just slap right into here. And the same thing on the other side. So we're just going to work our way out from the middle. This is really hard to do with one hand while I'm trying to film. There we go. So we've got our center frames in, and we'll just build off to the left and build off to the right. To get the frame started, I started by tapping in the center frame sections and then worked my way outwards. You can see here I'm putting in the bolster end, and I'm just indexing this using the slots provided. Once that's done, the bolster side gets tapped in, and then the corresponding bolster end, and then coupler pocket 1 and 2. Coupler pocket 2 has the little hoop in it so that you can chain your cars together. Then we'll slide the pilot in, and we'll take a nice look and see how everything goes together. Before we weld all this in, we need to make sure we have our coupler pocket top in place. If you weld in the sides without this part, you won't be able to get it in later, so you need to make sure that you have this part installed before you weld the sides on. You can see in this shot that the coupler top slides in between the two sides, and there's a slot that corresponds where the top will slide in. Once that's in, then you just put the coupler pocket bottom on and weld it in. Once we had all of our parts in place, we could finally weld the frame up. Heat control is critical when welding cold rolled steel, so when you weld your frame together, I recommend only doing a weld about 1 inch long and moving around as much as possible. If you weld too long in one place, you run the possibility of warping your floor sheet, and that can be really problematic. So take your time, put small welds down, and move around as much as possible to make sure you don't heat up any portion of the floor sheet too much to keep warping to a minimum. I used a magnetic square to assist in keeping everything true while welding the coupler sides on. I wanted to make sure they were square in reference to the floor sheet. When the sides were welded in, I flipped it over and welded the coupler pocket top in on the underside. I'd recommend this to keep the welds out of the pocket where your coupler will sit. With that done, I flipped it back over and welded the pilot in place, but only to the coupler pockets. With the basic frame welded in, we could start working on our fuel tanks. To get started on the fuel tanks, you will need your fuel tank ribs. The fuel tank ribs get located using the slot in the center of the fuel sheet and also slide over the center frame rails. To install the ribs, simply tap them into place using a hammer. All right, so as we're installing these fuel tank ribs, you can see down in here that I have placed a weld right where the fuel tank rib needs to go. If you do the same thing, not a big deal. You can just notch it out like I've done here, and then it should slide right over the top of the welds. So not a big issue. Pretty easy, just kind of tapping these in place, getting it close, just like that, she's in. Now that we've got these tapped in place, it's important to make sure that they're square. I do have these magnetic squares on, but the square that I get on those is not so great, so I've just been using a speed square to kind of making sure that everything's pretty square. This one's a little bit off. Square that up. This one's pretty good. So we'll go around and attach our fuel rails. So the lower rail will go right here as such. It'll sit right in this slot. If I can get it to sit in there. There we go, just like so. And then our upper rail will go in these slots down here. And this is designed so you can bend the sheet in places. We're going to do here in just a moment. I would like to mention, you can see that the ends are a little bit different from the inner fuel tank rib. This cutout is for a subwoofer that I'm going to install, and you'll see that later in the video. If you aren't going to put sound in your vehicle, I would recommend probably just using 3 of these end pieces so you don't have this cut out. This is right where the sub's going to go, so I needed the clearance. But if you're not doing sound, that's a good way to do it. I also designed this so this can be removable. I'm going to weld mine. I have no reason to take the fuel tank off since the speaker plate, as you'll see here in a bit, will be removable for servicing. But those are some things to consider when you're cutting your locomotive if you're going to use sound or not. So what I'm going to do is I'm going to come in here and just tack these in, and then I'm going to tack all of my support pieces in, my fuel tank rails, and then once that's done, we'll get to bending. Now, before I install these fuel tank rails, specifically the upper one, I want to tap and drill all my screws first. The holes that are in the locomotive, the entire locomotive, are a little bit undersized, so you'll need to come through with whatever tap drill you decide. Most of the 3D printed and detail parts are 3 millimeters, and everything else is 10 by 32. So I'm just going to come in here real quick, just clean out the hole with a tap drill, and then I'm going to come in with my tap and tap this hole. And the reason that I'm doing this now is because when I weld these to the locomotive, I want to attach the speaker plate to it. That way I know when I go to reinstall the speaker plate that all of my holes are going to line up. So I'm going to go ahead and tap these 6 holes on this lower fuel tank rail, and then we'll go ahead and we will weld all of our fuel tank rails to the fuel tank. All right, so we got this entire thing mocked up. All of these are square. I have the speaker plate as well as the lower fuel tank rails mounted. You can see why I did this. I tapped these holes to make sure that when I pull this speaker plate off, if things move around, that all the holes will still line up. So as it is right now, everything is square, at least on this side. So what I'm going to do now is I'm just going to come in here and tack my edges, and then I'll move to the other side and make sure everything is square. And then we'll put on our upper fuel tank rails, which look just like this, and they'll go right up in here.
While I'm tack welding the fuel tank ribs in, let's talk a little bit about the removable fuel tank option. I designed this tank to be fully removable if you wish to build it this way. I chose to weld my tank straight onto the chassis simply because I have no reason for it to be removable. But if you want these to function as actual fuel tanks, this would be a good method so you can remove the tank assembly for service instead of welding the tank ribs to the frame and the floor sheet. So if you want your tanks to be removable, make sure when you cut your files you get the fuel tank mounts. There are 8 mounting holes, 4 for each compartment, and it's designed to be screwed in from the top of the locomotive into the mount. Now that we have all this tacked in place, why don't we go ahead and start bending our fuel tank sheet.
Now that we've got our fuel tank structure built, we've got our upper and lower rails installed, now we can go on to bending the sheet that goes over the top. Down here on these little creases on your parts, you're going to see there's some slots. That's designed for this to just slot right in there. So I'll go ahead and take my fuel tank sheet. I'm just going to press it in the slots just like so. And I'm going to kind of get it equalized. Now, I think there's a couple ways you could do this. I think this, using 18 gauge steel, mind you, I think you could actually form it on the vehicle, you know, giving it a bend, tacking it, bend, tack, so on and so forth until you work your way around. If you have a metal brake, this would probably be a good thing to use. In this instance, I do have a metal brake. It is broken, and I don't want to go on a side quest to fix it. So what I'm going to do is I'm going to take a marker and just mark where my bend starts here, and then I'm going to use it. I'm going to put it on the table, clamp it down, maybe around a pipe or something, and then preform it just enough that the profile is pretty correct, and then I can force it the rest of the way. I think that'll work out pretty well.
This is by far the most difficult part of the build. Getting this fuel tank sheet to form right is a little bit tricky, but the methods that I used in this video worked pretty well. To start us off, I marked my pre-bend line when it was mocked up on the mount. To pre-bend the part, I just lined up the bend line to a table edge and then I clamped the sheet down using a 2x4. Then I was able to place my pre-bend on the line that I wanted and use the table to bend the part accordingly. Once this was done and the bend looked like it was in the right spot, I took the sheet over and tacked it in place into the mount. Now this is the tricky part. To get it to conform to the mounts, I used 3 ratchet straps. I would tighten each of them a similar amount and then weld that section of the fuel sheet to the fuel tank rib. I then repeated this process until I had worked it all the way around the mounts and into the form. This worked out pretty well actually. My fuel tanks weren't perfect by any means, and I did have some odd spots that didn't contour to the mount as well as I would have liked them to, but overall, for the average builder, this is a good method to use. Just take your time and it should come out nicely.
All right, so we got our fuel tank sheets bent. I would give my craftsmanship a solid C+. This side was my first time really ever forming metal, and there are some imperfections. This side turned out a little bit better. If you know how to bend metal, this is gonna be no problem for you. I just used it, as you saw, I used the ratchet straps and used the fuel tank ribs to form the metal. The pre-bends down here on the bottom were very helpful because you were able to mark it. On the top, it was hard to locate where that bend would be, but at the end of the day, nothing handmade is ever perfect, and I think it'll work fine once it's painted. So we're gonna go ahead and move on to welding the rear bolster. I'm gonna wait to weld the front bolster because we need to actually flip this whole thing over and kind of mock up the cab area where the Predator motor is gonna sit. And those holes are going to be located inside of this bolster plate. So if I welded this bolster plate on, there would be no way for me to weld nuts in or be able to service the Predator engine. So we're going to weld the back bolster and then we'll flip it over, do some mock-up, drill some holes, and then we can finish up with the frame section of the locomotive. So the bolster slides in here like this, and the bolster pin needs to go all the way through the floor sheet, or it should. The bolster pin that I got was not long enough to go through the floor sheet and then the bolster plate and then have enough room to get the cotter pin in on the top. So what I'm going to do is I'm just going to tack weld this in. It should be fine. And then I'll weld all of this together. So the pin will get just lightly tacked enough that it'll hold it in place. Now, flip the whole thing over. Weld it up. It's much more rigid with the bolster plate on. That's going to be fantastic. So now that we've got that welded on, we're going to flip it over, and I think I'm actually going to put it on the trucks. We're not going to weld this one. We're just going to mock it up and set it in place, and then I'll be able to mock up the cab, drop the Predator in, and we'll be able to drill our holes and finish out the bottom section of the frame. All right, so we've got it flipped over. It's sitting on the trucks. Now I'm going to go ahead and start working on the nose of the locomotive. As I said before, I would like to put a Predator engine in this. I'm not sure if it's going to fit, but there's only one way to find out. I'm going to go ahead and kind of tack everything together here up front. And I'm going to start here, with the front cab portion. I'll build the nose, and then I'll build the side and just to the rear parts. This is where the builder needs to decide how they want to put together this locomotive. I've designed this so that the entire top can lift off. I would highly recommend building it this way. The reason being is if you get a bunch of batteries in here and you have a motor and you need to get in to service it, you can take the entire body off almost like an HO scale model would. If you weld it to the floor sheet, you're going to get a little bit more rigidity, but you're not going to be able to remove that body. You'll see later in the video that we have the option to remove just the dynamic top as well as the upper radiator section. But if I was you, I would build this with removing the body in mind. And you know, there's holes that are pre-drilled here, ready to accept some brackets. I'll probably put some extra ones in. This is where you as the builder gets to decide where to go forward from here. So I'm gonna go ahead and get started tacking all this up. And before you know it, we're gonna have something that looks something like a GP40. All right, so this looks like a hot mess express right now. Something I wanted to mention is this whole nose section is grind to fit, meaning that you need to put a little bit of a bevel on your parts. So this is nose one, and the bevel on the inside allows these parts to sit together nicely. I also put a bevel on each corner of these front nose two pieces, and then the same thing on nose three. And this bevel kind of allows everything to sit nice, and then we can weld it and then kind of smooth it out and contour it with the grinder. So now that all my bevels are good and in place, I'm just going to mock everything up, tack everything together, and then we'll continue moving aft. Just kind of doing a test fit, grinding as I go. You want these slots to be easy to have these parts slide in and out, because once you weld everything together, you want to make sure that it's pretty easy to drop this whole assembly in. And that looks like that should work. Yep, that'll do. That looks much better. That should be strong enough now. We should be able to pull, like a glove. So that's a good indicator that everything fits right. It just snaps right back down into place. So that's pretty good. So now we'll continue moving our way aft. Again, making sure all of our parts are squared down, sitting nicely on the sheet. Looks like they're sitting pretty good. So we'll continue working this way, just kind of tacking everything together, and then we'll flip it over and burn it in real good. I'm happy with that. This is a good time to add some rigidity, just because we're going to be moving this piece on and off. So I'm going to go ahead and install the walkways. This is the left walkway front piece. You can see this slot here. Just slots right in there nicely. And then the left walkway top just goes right on there too. So we'll just tack this in, make sure everything looks nice and level and square. And remember, we're not going to weld this to the floor sheet. We're just going to weld this to the nose section. And then when we bring in our left cab part, we'll be able to kind of tack everything in. And hopefully everything will be pretty rigid when we lift it on and off, because I really don't want to have problems with this bending and moving around as we work on it. So anything I can add to give a little bit of rigidity in this time is going to be A-okay. So to kind of mock this part up, I'm going to use my little square here. Just kind of bring it in so this part looks square. This is cab step. There's 3 of these. There's 1 on the left side and 2 on the right side. I can just bring this in here and make sure that looks pretty square, and it does. And then I will also reference this, and it looks good too, so I'll go ahead and tack this in. Bring in our top plate, set it in there. It's sitting square on there, so that looks good. And I think I will bring in the cab step as well, and to square this up so it doesn't sit and fly around all mimbly-bimbly. Our left cab piece is just going to come in and sit just like so. And you can see the detail and the steps that we've got there. These are going to be doors that we'll cover up, and this is a 3D printed handbrake. So all these little gaps will be filled with detail parts at some point.
I then repeated the same process on the other side. Here we are welding the right cab walkway top and front parts into the nose section. Again, it is absolutely critical you don't weld any portion of the body to the floor sheet itself unless you plan on welding the body to the frame permanently. If you weld these parts to the floor sheet, you won't be able to remove the body for servicing, so keep that in mind. We are now getting to the part where I can check the fitment with my 6.6 horsepower Predator engine. This GP40 was designed to be as scale as possible, so the only place this engine could theoretically live will be in the cab. I temporarily mocked up the cab sides and the rear portion to see if it would fit.
We're at the moment of truth. I want to see if this Predator engine fits, and I have my doubts, but there's also things we can do to edit this engine so that it will fit, such as taking off this big ass annoying exhaust, relocating the fuel tank, etc., etc. I'm also going to lower my lift down so I don't have to get all the way up there. A Harbor Freight special. Let's see, does it go this way? Oh, it is going to be really tight. Like, really goddamn tight. Shit. Oh! Oh! Holy it. That's would be the correct term. But it does fit. There's zero room for error in here. In fact, I don't even know. Pull the pull start.
I messed around with this engine for far too long. For this engine to fit, you will need to remove and relocate pretty much everything. The exhaust, fuel tank, and anything else that protrudes very far would need to be relocated. There just isn't much room inside the cab, but that doesn't mean that it's not fully possible. It's just going to be up to you as the builder to figure out how you want to install your engine.
All right, so after about 2 hours of messing around with this engine, seeing if it will fit, I have come to the conclusion that it will fit. However, it is tight. I mean, there are interferences everywhere. I mean, just the air intake for the carburetor, the exhaust where it comes out. I'd have to make an entire new exhaust, which isn't a ton of work, but it is work that I would have to do at some point. So I think I'm going to take the executive decision, and I'm just going to go all electric with this vehicle. But you could fit a Predator 212 engine in here. You're just going to have to do a little bit of engineering and a little bit of relocating. For my application, it should be fine. I plan on using this locomotive just kind of around my yard. My club's pretty close. I would like to take it to Train Mountain someday, and that was the idea behind having the engine in here, but I'll have to make a generator car. I will be looking at some different kinds of batteries other than lead acid batteries that I might be able to extend my range, so that's something that I might be able to do. But it's just going to be a lot of work to make this fit. I am planning on coming out with an F unit, hopefully by the end of summer, and this engine would be perfect in the F unit because the F unit has the same dimension as the floor sheet on this, except it is the same dimension all the way down the sheet. So instead of working in this teeny tiny little box, I'm working in a box that is way bigger. So this engine would totally fit in the F unit. So I'm not going to bother drilling holes for this. I'm just going to go full electric. And if I do decide to bring an engine in this at some point later in time, rather than bolting it all the way through the floor sheet, I'll just make my own little welded bracket because it's not so much of an issue of height with this engine. It's an issue of completely maxing out the available space that's in here from the lateral and the horizontal standpoint, not the vertical. So I'm just going to go ahead and take the engine out. We're going to go all electric on this build. Shouldn't really change things too much. I actually think it might be a little bit nicer. And we're just going to continue welding all the way back. I'd like to get the body mostly tacked together, and then I'll take it off and we'll flip it over, finish the bottom, and paint it, and then flip it back around and finish up the locomotive. So we'll continue welding.
Before I flip this over and finish welding up the underside of the engine, I decided to finish up the cab. To do this, I grabbed my left and right cab sides and the cab rear panels and welded it all together. I also welded the cab roof sections into place. I'm trying to weld this enough that I can pull the cab assembly off and move it around and not worry about bending it or deforming it. This way, when I go to reinstall the cab at a later point, all the tabs line up just as they did when we welded it together.
Okay, so we've got our cab pretty well welded together. This is going to be probably the most difficult part of welding this whole locomotive together, and that is our number board assembly. So we're going to start with the lower number board, and there's these two slots right here just above the cab windows they're going to live in. I'm going to hold that in there, and then I'm just going to take a square, and I'm just going to kind of try and get it centered. And you can do this by eye. There's also, you can look at the back of the locomotive and see where the slots are at. You can look and see if this is centered in the slot. And that looks pretty good. So what I'm going to do now is I'm just going to tack this. I'm going to tack it very lightly because I want to be able to move this part around. And you'll see why here in just a second. So I'm just going to take a welder. I'm just going to give just a little kiss. Just enough that it holds it in place. So now I'll go ahead and carefully take my square off. And now we'll go ahead and do the number boards. There's two of these. They go like that. And the headlight, which will sneak in here just like so. So I think what I'm going to do is I'm going to come in here and I'm just going to center the headlight in the slot. Just give it a light tack. I'm actually going to tack this on the front. Just enough that it's close. And I can still kind of bend it a little bit. And I'll come in and do the same thing with my number boards, making sure that they are not upside down. Lining up my corners there. This is pretty tight assembly here. I designed it this way so there was minimum Bondo or welding however you want to do this. Just matching my corner. All right, so this is where things get a little bit tricky. This part is designed to sit just down in here like so. And it's supposed to be at the same level as the cab lid. There should be a little bit of a lip right here. And this is for the cab lid so that it provides a nice flush and seamless transition between the number board assembly and the cab lid. So you can see here, that's going to sit just like that. And it's probably worthwhile welding it in place like so, just so you know that everything lines up. But the tricky part is you can't really, there's not a whole lot of room for it to sit on this front piece. So it's going to be kind of a pain in the ass to get it all welded together. And the cab lid might be sort of grind to fit depending on how well you do this, which is fine. We got grinders, we got welders, we can fix it. This is designed to be two separate pieces, so when you take the cab lid off, your number board assembly stays in place. Just some tiny, tiny tacks. And that should be good enough to kind of hold everything in place while I get it right where I want it. Here's a little better shot. So the cab lid should be aligned with the front part of the locomotive, and there will be a little gap in here. You can fill that with weld, sand it down, Bondo, grind it, smooth it into the surface here. So it should have just like an 1/8 of an inch gap that you can weld to. You can kind of see it right there. So that's in a pretty good spot. I'm going to go ahead and tack the bottom here, or weld the bottom in a little bit better. And then I'll get up in here and weld the top. And then we should be good to pull the cab lid off.
Once the number boards were where I wanted them, I welded them in permanently. It is important to note that the cab lid is designed to be removable, so I'm not welding the number boards to the cab lid, I'm only welding them to the cab itself. I did have to place some welds on the front of the number board assembly, so I came back afterwards with a grinder and smoothed everything out.
All right, so the whole number board section's done. The cab lid, you can see, just lifts on and off. I think I want to flip the floor sheet over and finish welding on the bottom. We've still got to weld the stairs in as well as some of the side trim pieces. So as I have been talking about through this whole thing, this cab is removable as long as you didn't weld it to the floor sheet. So it should just, whoop, just like so. And then when we're ready to put it back on, you just line up all the tabs and you drop it in just like so. It's probably going to be a little bit of a bastard to get the tabs in and out, but it's really not designed to be done all the time. But if you do need to service the locomotive and you'll need to remove the whole body, it'll work. So I'm going to go ahead and lift off the cab, set it over here, and we're going to finish up the welding on the bottom of the locomotive.
Once I had the frame flipped over, I decided to start working on the steps. For this, you will need your step front, step side, and all 3 steps. To start, I installed the step front piece and tapped it into place. I then tapped in the step side and welded them in place once I thought everything looked nice. Once everything was welded in place, I could then weld the steps in. I started with the top step and worked my way down. As long as they look straight, they will look totally fine. I then repeated this process on the other 3 corners of the model. With the steps welded in, we can now install our side trim parts. It's important to note that the GP40 has a left and a right side, while the GP38 is symmetrical on both sides. So if you're building a GP40, make sure you get your trim on the correct side.
All right, we have got our side trim piece welded in place. There is one thing I wanted to mention. You can see all these little screw holes that are down here on the end. This is where your stanchion is going to mount. So when you're welding on the back side of this, it's important to keep these screw holes clear. That way, when you come in with your pilot drill, you don't snap your drill bit and have problems tapping. So just keep that in mind, but I think we're ready to move on to the end trim.
To finish up the trim, you will need your end trim and your side end trim pieces. I started by welding the end trim section in place, and then to finish it up, I just lined up the end parts with the floor sheet and welded them in place. The last thing we need to do on the bottom of the locomotive is mark and drill the holes to bolt in the coupler. Every coupler is a little bit different, so determining how much movement you want side to side from your coupler and how far out it needs to be to accommodate a plow or not determines where you drill your hole. To do this, I grabbed my coupler and I set it on the coupler pocket. I did a little bit of measuring and maneuvering to get it where I thought it should live, and then I drilled my holes. I drilled all the way through both coupler pocket pieces. With the holes drilled, I grabbed the bolt and the nut for the coupler mount and welded the nut only to the bottom of the coupler pocket. If you weld the nut without the bolt installed, you run the risk of the nut warping enough that you can't reinstall the bolt later on.
All right, that is it for the welding on the floor sheet and the frame and the underside of the locomotive. We are completely done. There will be no more welds on the floor sheet. So now what we're going to do is we're going to flip it back over, put it back on the trucks, and we're going to finish the rest of the body. All right, so before we put the cab back on, there's a couple of little things I want to do. There are 4 holes that are located here at the intersection of the cab, and these are going to be some mounting holes. So before we install the cab, I'm going to come in with my 1032 tap drill, which is 5/30 seconds, and I'm just going to drill out this pilot hole. One there, and then these 2 have already been done. And what we'll do is we'll come in here next, and we will tap these to accept the 1032 screw, and then you'll see how this will play once we install the cab of the locomotive. We also have the 3 screws in the back that I will show you. So there are these 3 holes here that will be used to screw the back part of the body to the floor sheet. We need to tap these with 1032 as well. Come in here and clear out our hole. And then we'll come in with our tap.
For all the holes that need to be tapped, you will need to clear the hole with a proper size tap drill. I designed these holes to be slightly undersized in the laser cut files. When the steel gets laser cut, it tempers the edges where the laser had cut, making it a bit harder, and I was worried that using a tap on a laser cut hole with no extra processing would ruin the tap due to the additional hardness. So all holes that need to be tapped will have to be cleared with the proper tap drill prior to tapping.
All right, so I've got my holes tapped and I'm ready to assemble the back part of the locomotive. To do this, we're going to need our side panels. But before I go ahead and weld everything together, I think I'm going to put the doors on first. I think it's going to be a lot easier to weld the doors laying down like so than it is to weld them on while they're sitting on the side of the locomotive. All the doors are designed to be welded from the inside, so there's no ugly welds on the outside of your locomotive, as is most of this locomotive. So really quick, you can see in this is my left side, and it's flipped around. You can see that I have all of these openings cut out for the doors. So if you're not really particular about how your doors are located on your model and you think what I did works great, you can order this piece right here that's already pre-cut, and locating your doors is going to be super easy, and I'll show you how to do that here in just a second. If you have a really weird locomotive, or there was 500,000 different door variations through GP40s and GP38s. So I also have this file in a blank model where the door cutouts are not available. So then you can decide where you want to place your doors. So choosing your doors, we've got door 1 through 1, 2, 3, 4, 5, 6. Had to count. So door 1 is going to be a long door without any latches. Door 2 is a long door with spaces for latches. Door 3 is a short door for spaces with latches. Door 4 is a blank short door. 5 and 6, you'll see here in just a moment, are going to be these smaller doors that go on the right side of the locomotive. So what I'm getting at is if you don't like the way that I've arranged my doors, there is a blank model available where these door cutouts are not there. And you can use that information that I just provided to pick and choose how many doors you need to cut out, and then you can put them how you want to. So why don't we go ahead and get started. I am using 3D printed door latches. All of my locomotive, I'm using my 3D printed files. There are also files available for precision steel car latches. The way that I'm going to do this is pretty nifty. I'm going to pull up a photo of where my doors are going to go. And then to be able to locate these doors, I'm just going to set my latch in here. And the latch sticks just far enough out the bottom of the plate that I can actually use the latch to line the door up. And these latches go right in the corner of these openings, and that door is located. It's that easy. There's no guesswork. They'll all end up being straight and level. And then, if you've got a blank door, you just do the door with the latch first. You bring it up, butt it up against it, and tack it on in. It's straight. They're in correct alignment as far as the alignment that I designed. I think it's going to work fantastic. So if you are using the printed latches and precision steel car latches, in my preset configuration, use your latches to locate the doors so that you know they're going to be square and level to the opening. So we'll go ahead and weld all these doors in, and then we'll install our side panels and get the body all the way put together. We got all of our doors welded from the back, so if I flip it over, you can see that, yeah, they're pretty straight. I think that looks really good. Using the latch to locate the doors seemed to really work nice, and the spacing is correct. Everything's lined up. So I would call that an A+ way of doing it. So this is the left panel. I'm gonna go ahead and do the right panel now, and then we'll weld all of it together. Every once in a while, I do something so stupid that I wonder how I even have made it to be this old. You guys see anything wrong with this picture? Other than the doors are on the wrong side? So when you go ahead and weld your doors together, you better make sure they're on the right side, because I get to cut all of these off. Weld your doors on the right side, kids. Okay, after that 2-hour scenic detour of the doors, we're gonna go ahead and put our nose section back on. Put it in the slots. Should drop right in. Wow, that was pretty choice. And now we're gonna go ahead and set our rear plate on, our side panels, and we'll kind of get everything mocked up, and then we're gonna put in our floor brackets that'll hold everything to the floor. So I'm just gonna kind of get everything mocked up, and then we're gonna come in and get all of our other stuff welded together. Yee-haw. Before I get started on the back section of the cab, I do actually want to bolt down at least the front nose. You can see there's these 4 holes right here that we tapped. You're just gonna slide that right in there. And then what we're gonna do is we're gonna come in and screw it down to the floor sheet. And then once it's screwed down, we'll take some clamps and clamp the entire nose section as tightly as we can get it to the nose. And then we're gonna weld this bracket to the cab. And the reason that we're gonna screw this down, then clamp the cab, and then weld it is so that it sits all the way down on the floor sheet as tight as it can get. So these screws will actually, when you screw this in and out, will help suck everything down and add rigidity to the structure. All right, it's all clamped down. So now we'll zip it in, give it the old zippity doodah. It's kind of hard to get in here, especially when I'm trying to film shit. Oh, look at this. Look at this nifty little spot.
While I'm welding this in, I think I want to make what I'm doing a little bit more clear. The body mounting brackets only get welded to the body of the locomotive, and these would be only used if you're planning on making the body removable, which again, I highly recommend. By screwing them into the floor sheet and then clamping your cab securely to the frame before welding the mounts to the cab, you are guaranteeing that they will be in the correct position. If you have any warping on your floor sheet from welding the frame, this step is critical because it will make sure when the body is screwed into the frame, it will add rigidity and straighten everything up in relation to the precision cut surface the bottom of the cab and the side panels will have from the laser cutting process.
All right, that's how we are going to attach basically the entire shell of the locomotive to the floor sheet. We're gonna wait on this bracket here until we get the rest of it built, but for now that should be pretty good. We are ready to do the rest of it. You can see on these back left and right panels, or rear left and right panels, I added a bevel just like I did on the nose. These are the same type of thing, grind to fit. So we're gonna go ahead and start with the left side of the locomotive. I'm just gonna have some squares ready up here. I'll go ahead and bring it in. Slide it in, drop it in the slots. There's the front. The middle and the back. Just gonna bring my square in, square it up, and then I'm just gonna check the fit here. Drop it in. Might need to grind it a little bit more or push it forward just a hair. Tight tolerances, my friends. Tight tolerances. Still getting a little bit of a fit problem here, so try that. Snug. It is tight. That looks pretty good. So what I'm going to do is I'm going to tack these corners together at the top and at the bottom, and then we'll tack the front, and then we'll repeat the same process on this other side. All right, we've got our whole back end ground to fit. Everything fits nicely, but before I weld this in, I think we want to put our cab steps in here. And these are just the other two that come off the back. This is important because once this is in, I don't think you can get these in. So I'm just gonna put a square on here and try to tack weld it as best as I can underneath this. And then once we have everything welded together, we can flip it over and weld it in a little bit better. But this is just to kind of hold it in place. Good enough it won't fall out. Make sure this is clean. Oh, good enough it won't fall out. Well, it just fell out because I'm a dumbass. There we go. All right, make sure our floor sheet's clean. We want this panel to sit all the way down on the sheet. With our square. All right, you can see we've got our rear body mounts screwed in and ready to be welded. And we also have the rear two body mounts up front screwed in and ready to be welded.
You will notice once the body mounts are welded to the body and everything is connected to the floor sheet, the locomotive becomes a lot more rigid. The body adds a lot of rigidity when it's completed enough you can mount it to the floor sheet, so if you're building this locomotive and notice that the frame of the locomotive isn't super rigid, once you put the body on and screw everything down tight, it makes the chassis completely solid. Alright, so we're doing some more body mounts on here. I don't know if I covered this a little earlier in the video, but as I welded the floor sheet, I had a little bit of warping issues, and so the way I'm going to correct this is you can see I've got this 2x4 that's ratchet strapped on both sides. What this is doing is this is pressing these side panels down into the floor sheet and kind of sucking them up together. And what I'm going to do is these are the removable fuel tank mounts. I didn't use the removable mounts, so I'm going to actually repurpose these as some additional body mounts. So I'm going to take two of these and put them on each side, so 4 total. And then what I'm going to do is I'm going to do the same thing that I did with the body mounts back here as well as the cab mounts. I'm going to put them in place, drill the hole, tap the hole, and screw the mount down, and then come in here and weld it once I know that this is completely flat. And that'll give me some nice rigidity that's going to kind of hold everything together and keep everything square. You can see here on the nose where I got some warpage. The nose isn't sitting completely flush against the floor sheet, so I'm going to do the same thing up here. I'm going to make a little corner mount, tap it, put the screw in, weld the mount with a clamp on it so that it's sitting totally flush. I'm not the greatest welder in the world, so you might get a completely flat floor sheet, but I did not. So if you do have the problems that I was having, you know, with the warps here and they're not sitting down completely flush, just make yourself some mounts.
All right, that mount is welded in, so now when I release this clamp, it stays flush. So we'll go ahead and remove that, and then I think we're going to move on to our aft rear walkway right here. Okay, so we're working on the aft rear walkway, and I think this is going to be a little bit tricky. So what I'm going to do is I'm going to take the end piece, I'm just going to kind of slide it in here, take my magnetic square, and just sort of square it up. The next thing I'm going to take is my aft walkway side. There is kind of a way for this. The holes should be closest to the top, and then on the aft side, the holes should be closest to the end. I don't know if you can see that on camera, but I'm just going to kind of set this on here about where I want it. Use the square to kind of hold it in place. Now, the reason this is going to be tricky is because, I don't know if you can see this on camera, but either the floor sheet or this piece was warped when it was cut out of laser steel. So I'm going to have to figure out a way to suck this down. Likely I'll end up making a mount that goes on the inside of here. However, we do have this top piece that slides down in here. So the order of operations to get this to go in correctly is going to be a little tricky. So what I'm going to do is I'm going to tack weld the side piece to the cab, and then I'm also going to tack weld the ends and the sides together, and then put in the top piece, see how it sits, and if I need to add a couple little mounts to suck it down against the floor sheet, then I'll do that, and then we'll flip it over and weld everything on the bottom so you can't see the welds. And it looks like it's staying down. That's awesome. So now we'll go ahead and release this clamp. We're going to take our top, slide it in here from the top just like so. Get it in the slot, get it in the back slot, drop it down into place. Up here we're sitting flush, but then it kind of sags as it goes down. So using magnets, I was able to kind of lift up this piece. So I'll just give it a little tack here, here, and then I'm not going to weld it to the inside because I want to do that when I flip it so there's no welds here to grind down. So we'll just kind of tack all these little pieces together, and then we'll flip the whole body over and weld the rest of it. Okay, so we're moving on to the top, so we're just about done welding. On the top, we're going to kind of work from the back forward. So the first thing we're going to want to find is our lower radiator plate, and that's going to go all the way back here. And I'm just going to kind of line this up by eye. It's not real important right now. We'll check the fit before we weld everything together. Get your dynamic plate, either with or without the printed parts, whatever you chose to cut. We'll just kind of set this on here, slide it back till it sort of gets close. That looks pretty good. And then we're going to need our cab lid. Now, the cab lid, I'm trying to decide how I want to build mine. I designed it so that it could be removed either with a hinge or with magnets. You can weld it in if you want. If you're putting a gas engine up here, I thought that it would be nice to be able to like lift it up, put gas in the engine or whatever, and be able to put it down like a lid. I'm not really sure how I'm going to do mine quite yet. You'll find out later in this video, I'm sure. But I'm just going to kind of set this in here. I'm going to line everything up as best that I can. And then once that's done, we'll go ahead and we'll tack in our upper radiator plate just so it doesn't move around. And then there's a couple of little mounts that we're going to need to put on the inside. And this is because the top of this is designed to be mostly removable. The upper radiator plate will be removable from this. The entire dynamic plate will be removable. And then the cab lid, if you choose to build it to be removable, will be removable as well. And this is so you can get in and service things inside without taking the entire body off. So there's a couple mounts here that are going to be used just to hold the plates down. And then if you need to remove something, you can get in and do that. So we'll just mock everything up here, and then we're going to need our upper plate mounts and our cab lid stops, as well as the upper plate or the center plate mounts, both 1 and 2. So we'll go ahead and find those. So I kind of shifted everything around and got a pretty good idea of where I think it should live. So here we have our upper radiator plate, and then this piece right here that goes in between the two side panels, this is our upper plate mount. And the way that this is going to work is we're going to send some 1032 screws in through here. And then if I grab my dynamic plate, this will set on top of here. This is all designed so that it's removable. And this piece will slide right up into here. And then this will also get attached to the upper plate mount using screws. Up here, we have a couple more mounts that we're going to install. So I think what I'm going to do is I'm just going to tack my upper radiator plate in. I'm going to go in and tap these holes and then put the screws in so that everything is kind of solid. And then we'll move up front and we'll put our upper mounts up here as well, which is the CP1 and 2. I think that's the best game plan, is to use your screws to hold everything solid while you kind of tack everything in place. Now that that's been tacked into place, what I want to do next is we can actually take this dynamic mount out of here. Now I want to do our upper plate mounts. So I'm going to go in here and tap all these holes to 1032. I'll come in, I'll screw this in here just like so. Then this is just to locate it. I'll weld in the bottom of this mount, and then we can bring this in, screw it down, and continue forward. All right, so we've got our upper plate mount in there mocked up. It is not welded in yet. I just wanted to kind of screw everything in and make sure that it fits. So I'll go ahead and take these screws out, remove the dynamic plate, and give that a weld on the inside of this. All right, so we have this all screwed back in. We welded that upper plate mount in. Now I'm going to go ahead and move forward to my dynamic plate mount. There are a couple pieces to this. There's this kind of a rectangular piece with the hole in the middle. So I've drilled and tapped this to accept a 1032. And what that's going to do is that's going to go right here. And you'll see how this is going to go together here in a second. But I'm just going to take this piece, just like it is oriented right here, lengthwise. I'm going to set it in here. I'm going to drop my screws, apparently. I'm going to screw it in just like so. And get it nice and snug. I'll do the same thing on the other side. Alright, so these are both now screwed in. So what I'm going to do is I'm going to come in here and just lightly tack weld the bottom of these. And then we have the other portion of our dynamic plate, the dynamic plate 2, which is these little gussets that you'll see here in just a second. Alright, so now those are tacked in place. We'll go ahead and take our dynamic top off. Now I know this seems like a lot of work, taking screws out, putting them in, putting them out, doing all kinds of crap with the screws. The reason that I'm doing it this way is because if I assemble it with the screws installed, I know that when I go back later on, everything's going to line up. I don't have to re-drill my holes, re-tap my holes. So just taking the extra time and thinking about what you're doing, I think is going to make this build a lot easier for you. We'll go ahead and remove our top. You can see I just tacked those two little pieces in there. And now we're going to take these little gussets. I'm going to weld just like so. The idea behind this is that you'll see a little bit later in the build, these are actually going to accept some steel eyelets as they did on the real thing, as well as two in the back. So with these gussets, it'll add enough strength that you can actually pick up the body with a lift if you decide to. So I'll go ahead and weld in these gussets and then we'll continue with the dynamic. Okay, so before I put the dynamic plate back on, I am going to do one more little weldy thing up here. So you can see we've got our mounts in here, we've got our nice little mount here, but we got to figure out how to mount the cab roof. Well, in your files, you will see there are two pieces of steel that are called the cab lid stop. And I don't know if you can see this on camera, but I just put some magnets in here, and the way that this is going to work is it's just going to sit right in here flush with these mounts. And the cab lid should just stick to the magnets. These pieces of steel are the exact same dimension as in between these. So the way that I'll do this is I'll weld it in between, and then I'm actually going to weld this before, just give myself a little bit of an offset so there's a lip for those magnets to sit on. And then when I weld that in here, I'll probably weld one in up here, sorry for the camera angle, so that when I put the cab lid on, the magnets just hold it and I don't think it should vibrate. I don't know, we'll see how it works, but that's how I'm going to do this. If you want to put hinges on, hinges are a great idea. You can use magnets to hold it closed. You can make a latch, whatever you want, but this is just how I'm going to do it. And that's what these cab lid stops are for, is to go in between here, and they're designed to catch the lid. Go. That's pretty freaking sweet. Magnets, how do they work? Magnetic lid test 3. Go ahead and set that in there, and then it just goes. It's so good. Adequate force to hold it and not let it vibrate. That is perfect. All right, so now we have the entire upper section is complete with the mounts. We're going to go ahead and continue with our dynamic, which I think is the most exciting part of the locomotive. So the dynamic, I understand, can be a little bit confusing. So there's 7 total parts. There's D1, 2, 3, 4, 5, 6, and 7. The way this is going to work is D1 is going to be furthest back, D2, D3, D4, D5, D6, and D7. So we're going to start with D1 and then we'll work our way around. So starting with D1, I'm just going to kind of work our way around. I'm going to go ahead and grab a magnetic square here. And D1 is going to sit in these upper slots right here, kind of up against the sheet. It's not going to be completely against the side panel. There's about a sheet metal worth of thickness and gap that's going to kind of hold it in place. So I'm just going to kind of get that lined up. I'm also going to center these tabs in the slots on the top here. And then I'm going to come in and I'm just going to give it a tack just to kind of hold it. And we'll go ahead and give it a tack here as well. And that's in place enough. So you can see D1 sits a little bit away from the actual side panel. So I think now we'll go ahead and we'll go to D3. And this is just going to sit right here on the front. And I'm just going to line up these corners with the corner of the dynamic plate. Just once again, I'm just going to tack it. Tack it. Tack. And tack. Okay, so there's that. Now we can come in here with D2. And it's just going to kind of slot right in there like that. This isn't going to be perfect, mainly because it's really hard to make sheet metal make shapes that it's not supposed to make. So there'll be a little bit of grinding and filling there, I'm sure. But I'm just going to go ahead and tack this in place as well. And I'm going to do the same thing with D4 on this side. Now I'm going to move on to D6. There are, if you did the 3D printed parts version, there are 6 holes, and they should be pointed towards the back of the locomotive. And the way that this is going to work, there's no tabs on this piece, but it should just touch off on the bottom here, just like so. And tack it. There we go, there's that. Now D5 and D6 are going to be kind of a, you're going to kind of have to play with it until you get it to go where it's supposed to go. So that's not quite right. Maybe it is. Maybe it goes like this. There we go. Wow, I'm actually surprised that that ended up fitting so nicely. Same thing with D7. There we go. That's how we put together the dynamic. Now, it's not perfect. As I stated, it's hard to make sheet metal do the things that you want. Like down here on the bottom, for example, you can see that this part of D1 is, it's just not going to work out because you would have to have this D6 part either cut on an angle to make it flush. So rather than designing it that way, I figured since I'm going to have the Bondo out anyways, I'll just come in here and fill all these holes with Bondo and shape it to get it where I want it. But I mean, it doesn't look that bad the way that it is right now. It is a little bit rough. I think Bondo would definitely help, but I think that that dynamic brake section looks pretty good. All right, so I'm going to remove the dynamic top. And again, there's the 2 mounting holes up here and the 3 screws back here. So 5 screws in total that hold the dynamic plate on. And it just goes boop, just like that. So now, if you ever need to get in here and service something and you don't want to take the whole body off, you can do so by removing the dynamic.
Now we're starting to get down to the smaller stuff. Next up was to finish welding the rest of the doors. We still had the rear doors and the nose doors to attach to the body. These doors might be easier to weld to the associated panels prior to building the locomotive body, but this way works fine too. It is a little bit of a reach to get these doors welded in this configuration, but I was able to make it work just fine, and my arms are teeny tiny.
All right, so putting on the plow steps and the plow trim, this is what your step looks like, and this is what your plow trim looks like. You can see I've drilled a couple holes in it, and I will show you why here in just a second. But we're going to start with the plow step. I'm just going to kind of set this on here about where I want it. Use my square to hold it. Now, there is this, this main step over here. You do have to kind of keep an eye out. And I don't know if you can see this, but I'm not putting it underneath this piece of steel. I'm just kind of putting the corners on top of each other. It's not the greatest way to do things, but to make the design kind of work the way that I wanted it to, that was the best way for me to figure out how to do it. So I'm just going to kind of get that aligned about where I want it. That looks pretty good. Then I'm going to come in here, and I'm just going to give it a couple welds on the back end. That looks awful, but it'll work. The plow trim, this is just for looks. Not really a huge deal if you want to put it on or not, but the drawing had it, so I added it in. And the way this goes on here is we're just going to kind of tuck this up underneath here. I'm going to flush it up with this corner right here. The whole point of this locomotive was to design it in a way where all of our welds were going to be on the inside or minimal grinding, because I hate grinding. So these holes right here are actually where we're going to weld it, because I didn't want to weld around the outside and then have these ugly ass welds. I wanted the real crisp, you know, corner there. So we're going to do what's called a rosette weld here. At least I think it is. Let me know in the comments. And I'm just going to take my welder and I'm just going to weld around the middle of the inside of this hole. Like so. Do the same thing here. Perfect. That's plenty good to hold it. So I'll come in here with the grinder and I'll clean these welds out. And like here, you can see there's still a little bit that didn't get welded all the way through. And I'm going to come out in Bondo anyways. So that'll be a nice way, if you prefer to do it this way, to keep the welds from being on the outside, because there's no way you'd be able to grind that down. So now that we've got the rear pilot done, I'm going to show you guys how I'm going to mount my AccuCraft plow. So we'll go ahead and move over to the front and do that. Up front, we've got our plow. I bought this from AccuCraft. I think Precision Steel Car also sells plows. They might be just a little bit different. But I want this to be about an inch up off the ground. So I just have this piece of 1x1 square tubing. I'm just going to set here on the rail. And then what I'm going to do is I'm just going to take my nice little plow and I'm just going to kind of set it on here and square it up as best that I can. Now, this AccuCraft plow comes with some mounts, which is an important thing to talk about. So the way that these mounts work is one part is threaded, so that will get threaded on the back end of this. And then there's these two holes that you can use to mount the plow to the actual pilot. Now, I don't want to drill holes, right? For one, because it's easier just to weld it. Two, if I drill these holes in here to mount this mount, they're going to end up going right through here, and then I'm going to have these ugly ass bolt heads sticking out right where the steps are at. So what I'm going to do is I'm just going to set this on here. I'm going to screw the mount onto the plow. I'm just going to tack it. I'll remove the plow, I'll weld it fully, and then I'll put it back in. So another thing I'd like to fix is once I put the coupler in here, for it to have any usable distance, right, it's going to have to sit out quite a ways. Like, I'm pretty much just going to slide that in basically until I'm confident that the bolt's going to hold it, and that's going to be it. But then when you look at it from the top, it just looks kind of stupid. Like, it doesn't look finished. You know, there's this weird coupler shank, and you can kind of see the spring here. So what I'm going to do is I'm just going to cut a little piece of steel that'll go down in here, and I'll cut it to the width of these tabs right here, and then I'll just weld it on so that once this whole plow is on, you'll only see from this part of the coupler shank forward, and I think it's going to look a lot better. Now, when you put this mount on, the plows are going to be different. If you buy one from Precision Steel Car, it's going to be different from AccuCraft. So if you do decide to do a plow, just know you're going to kind of have to modify it and do things to make it how you want it. It snows here a lot. And when I start building the Kings Peak Railway out there, I would like to be able to go out and play with some snow. So plow is going to be super cool.
To get the plow mounts welded up, I attached them to the plow using the included hardware. You can see here that I'm using a tape measure to check the plow is centered within the pilot. Once I was happy with the placement, I clamped the plow to the pilot and welded the plow mounts only in place. Next up, I welded the small piece of steel to the top of the plow to cover up the coupler shank. If you don't want the plow on your locomotive, you would just repeat the same process we did on the rear pilot by welding all the pilot steps and the trim to the face of the pilot.
All right, let's mount this puppy. All right, those are snug-ish. And then we'll throw the coupler in here for good measure, and boom. That's what it is. I think that adding this piece makes it look a lot nicer. It just looks a little more finished, even though I did a really crappy job of cutting that. But it is what it is. The only thing I think we have left to do is to weld on the wind wings. I'm going to do some work in here. We're getting pretty close. This thing's just about welded up. All right, so moving on to the cab doors. These two doors right here, I would really like to use as like a charging port, or like being able to turn the locomotive on and off without having to completely remove the roof. So I'm going to do magnetic doors just like I did with the cab roof stop. So I've got this little piece of metal that I cut out to be the inside dimension of here, and then 3 magnets. What I'm going to do is I'm just going to kind of slide this up in here like so. I'm going to take my magnets. I should have done this a little easier. Put a magnet here, magnet here, magnet here. And I'm just going to kind of slide it up in here like so, keeping the magnets out of the way as much as I can, just like that. And then I'm going to flush the magnets up with the bottom of this piece of steel that I'm going to weld in. That looks pretty good. So I'm just going to take my clamp, shove it up in here if I can. I can go ahead, tack those in place now. And let's take it for a test drive. I've got my cab door here. I'll have latches that it'll kind of sit down in, and it should just go clink, just like that. And the latches will hold it just there inside. And if they don't, I can glue some more magnets on the bottom. But that way, when I want to come in here and remove it, I can remove it, charge, turn the locomotive on and off, whatever I want to do. This is going to be my central access hatch, and I can just magnet it back on, just like that. So I'll go ahead and repeat the same thing on the other side, as well as for this little small cab door here. I think this pocket's actually going to be pretty nifty. I can maybe keep some spare parts in here for the 3D printed parts if I want. Anyways, I can, or my snacks, I can put a bag of Cheetos in here. This will be the Cheeto hole. So I'll go ahead and finish that on the other side. There's only one thing we have left to do. As far as I can remember, our list of parts is getting pretty small. These are all the parts that are left in the box. These are the doors for the other one. These are all spare parts. We are down to our last couple parts. We'll go ahead and finish off with the wind deflectors, and then we'll call it a day. All right, on to our last welded part, the wind deflectors. So the way I'm going to do this, I'm just going to kind of set this up here about where I want it, and then I'm just going to take this square. I'm just going to magnet it on there. You can align this however you want, put it wherever you want. There is one thing you want to keep in mind if you're using 3D printed detail parts, is you need to make sure you can still get the window frame in there, which will slide up and in like that. So it looks like this is a fine orientation. I'm going to take this tape measure, and I'm just going to make sure that it's centered on the body. So that's 1 15/16. 1 15/16 on the first try. So it is ready to get welded on. It looks pretty straight. Now I want this to look like it's got some hinges on it, so I'm not going to weld all the way across. I'm just going to weld probably like, oh, I don't know, a 1/4 inch here and a 1/4 inch here, and leave the inside blank so it looks like it's got hinges. I'm too lazy to make it actually function, but it should work fine. So I'll go ahead and just tack this in. That's it. So I'll come in here, I'll grind these welds down flush, and then there'll be this little gap that'll look like, kind of like a hinge.
With the welding finished up on the top side, we just needed to weld a couple smaller spots on the bottom. For this, I unbolted the body from the frame and flipped it over, giving me access to the underside of the aft walkway, the rear cab steps, and the inside of the side compartments of the cab. Welding it this way ensures my crappy ass welds will be hidden from prying eyes, and I think it makes for a cleaner finished product. With all that welding done, we could power down the welder, shut off the bottle, and gracefully send it back to its home.
Wow, that actually was pretty good. Well guys, that's a wrap on this video. Thank you so much for watching. If you want to support my channel, hit that subscribe button. It's free. And if you want to build something like this in your garage, head over to my website, J.T.Engineeringmodels.com. Download your files for my GP40. Or if you're not quite an experienced welder and want to try an easier project, the Caboose is going to be a great project for a beginner. I'm so stoked about how this locomotive is turning out. If you're deciding you want to build this, make sure you hit that subscribe button and keep an eye on my channel because I've got 2 more videos coming out. The next one's going to be getting it ready for paint, installing all of our 3D printed parts, and then the one after that's going to be the control system. Until I see you guys again, I hope you have straight track and you have a good time railroading. See you guys next time.